All right, hello everybody. We're working today on working with I and how we do arithmetic, how we add, subtract, and multiply complex numbers. So I'm just going to go over the answers to our exit ticket from today. Please ask questions. This is, remember, just a check-in where you're supposed to be and gives me some feedback on how you're doing and how I'm doing and what adjustments we need to make. So please ask questions. So in the first one, I'm trying to solve x squared equals negative 20. That sounds hard. I'm going to do a quick reminder. If I wanted to solve something easier, like x squared equals 9, then I would take the square root of both sides and I'd get x equals 3. But I'd also get x equals negative 3 because two negative numbers also square to equal positive. So negative 3 times itself is 9, positive 3 times itself is 9. So I'm going to do the same strategy for x squared equals negative 20. Take the square root of both sides. So x equals either positive or negative square root of negative 20. Now that doesn't really feel like I've done anything. Remember that the square root of a negative number is I. I can make the number negative 20 into negative 1 times 20. And I can make that answer into plus or minus I times the square root of 20. 20 is not a perfect square, but if you grab a calculator, square root of 20 is 4.5-ish, 4.47. So we've got plus or minus 4.47i. Just a tiny thing. A lot of times we write the letter I in front of the square root, but then we write it after the decimal number. Not like you really have to. It's just easier to read it that way. That's number one. Number two, we've got negative 7i squared. One thing I want to point out is that the negative is not included in the squared. The squared applies to the 7i. So I write that piece down twice. And then I go 7 times 7 is 49. I times I is negative 1. All right, 7 times 7, I times I. So I have a double negative 49. That's positive 49. So that's it for that side of the exit ticket. Let's flip over to the other side. Here we go. We've got k and m. Those are just two different complex numbers. Nothing really too. Actually, let me zoom in. Why is it so small? What good does that do? Much better. So we got k and m. So if I want to do k plus m, I'm just doing 3 minus 4i plus negative 2 plus 9i. And so, like we worked on, you're just adding your like terms. You're just adding your real numbers, and you're just adding your imaginary numbers. So 3 plus negative 2 is 1. Negative 4 plus 9 is 5. So I have 1 plus 5i. Double check that it's in the right form. Yep, real plus imaginary. K minus m. 3 minus 4i minus negative 2 plus 9i. So I just do 3 minus negative 2. Be very careful. It's not 3 minus 2. It's not 3 plus negative 2. It's 3 minus negative 2. So minus a negative means I'm doing 3 plus 2. Negative 4 minus 9 is negative 13. And that is also in the term a plus bi. If I wanted to be really pedantic, I could say it's 5 plus negative 13i. But I'm okay with 5 minus 13i. Last one, similar to what we did on the last page with negative 7i squared, here we have negative 3i cubed. So cubed means I write it down 3 times. Notice that the negative doesn't get written down 3 times because the negative is not part of the parentheses. So here I've got a negative, and then I've got 3 times 3 times 3. and I times I times I. 3 times 3 times 3 is just 27. I times I times I, we've talked about it in class, but you can break it down again, is negative 1 times I. And why is that? Because I took the first two i's, I squared is negative 1. So I took the first two i's and made it into a negative. The third one was left out. So I have negative 27 times negative 1 is positive 27i. Is that in the correct form? A plus bi? Almost. 0 plus 27i. I'm just going to be really specific so that you can see that here is the real part and here is the imaginary part. So thanks for watching. Please comment. Let me know if you have any questions, and we'll keep working with complex numbers.